Lesson 17, Managing State. 1. Introduction, Managing State. When your application starts to grow, it becomes important to manage state in a structured and deliberate way. Poorly organized state, or having duplicate pieces of state that represent the same data, is one of the main sources of bugs in applications. In this lesson, we'll explore how to organize state effectively, keep your state update logic clean and maintainable, and share state between components, even when those components are far apart in the tree. 2. Reacting to input with state. In React, you don't manually change the user interface with commands like disable this button or show that message. Instead, you describe what the interface should look like for each possible state of your component, for example, an initial state, a typing state, or a success state. Then, you connect user actions, like typing or submitting a form, to state changes. React takes care of updating the interface based on those state changes. This approach helps you think like a designer, not about how to change the interface, but what the interface should look like in every situation. 3. Choosing the state structure. How you structure your state can determine whether a component is easy to maintain or a constant source of issues. A key rule is that state should never contain redundant or duplicate information. If you store unnecessary state, it's easy to forget to update it later, leading to inconsistencies. For example, if you store a full name that can be derived from a first and last name, you risk having the full name fall out of sync when either of the two parts changes. Instead, you should calculate values like that directly from the existing state. This simple change can prevent many common bugs and keep your components predictable and easier to debug. 4. Sharing state between components. Sometimes, two components need to stay in sync. For instance, when activating one panel should automatically deactivate another. In these cases, it's best to lift the shared state up to their closest common parent. Instead of each component keeping its own copy of the state, the parent component owns the state and passes the necessary data and event handlers down to the children through props. This approach ensures consistency and makes it easier to coordinate how components behave together. Lifting state up is one of the most common and powerful patterns you'll use when writing React applications. 5. Preserving and resetting state. Every time a component re-renders, React decides which parts of the user interface to keep and which to recreate. Usually, React automatically preserves the parts that correspond to the same component type and structure. However, there are cases when you might want React to reset a component's state. For example, in a chat application, if a user switches to a different conversation, you may want the input box to clear automatically. To achieve this, you can tell React that each conversation should be treated as a separate component instance. React will then discard the old state and create a fresh one, ensuring that each chat behaves independently. Understanding when to preserve or reset state helps control how your interface behaves as users interact with it. 6. Extracting state logic into a reducer. As applications grow, components can accumulate multiple pieces of state and many event handlers that update them in different ways. This can become difficult to manage or reason about. Reducers offer a structured solution by moving all the state update logic into a single pure function outside the component. Your component becomes much cleaner because event handlers only describe the action, such as adding, changing, or deleting something, while the reducer function specifies how the state should change for each action type. This separation makes your logic easier to maintain, test, and extend as the application evolves. 7. Parsing data deeply with context. Normally, you pass data from parent components to child components using props. But if the same piece of information needs to be used by many components, or passed through multiple levels, this can become cumbersome. Context provides a way to make data available to any component in a subtree without explicitly passing it down through every level. For example, a heading component might determine its display level based on the section it's in. Each section provides its own level information to components below it. Context allows this kind of implicit communication, helping you avoid long chains of props and keeping your component hierarchy cleaner. 8. Scaling up with reducer and context. Reducers and context become even more powerful when combined. Reducers give you a clear, centralized way to handle how your state changes, while context lets you share that state and its update functions with any component in your tree. Together, they form a scalable pattern for managing complex application state. A parent component can manage its data using a reducer, then provide both the current state and a way to dispatch updates through context. This allows any nested component to read and update shared data without manually passing props down through multiple layers. It's a foundational approach for building large, maintainable React applications where different parts of the interface remain synchronized and consistent. 9. Conclusion. Managing state effectively is one of the most important aspects of building reliable and scalable React applications. You've seen how to structure state thoughtfully, avoid duplication, share it between components, preserve or reset it when needed, and centralize its logic using reducers and context. Each of these techniques builds upon the previous ones, giving you a complete toolkit for handling the growing complexity of your apps with clarity and confidence.